A very warm good afternoon to all of you. This is Maria Pushpam, and I'm happy to see you once again. And in this class, what are the things we are going to see are curve fitting, methods of least square, significant figures, and computational rules. And I'll warm up the thing what we have seen previously. Previously, what are the things we have seen in this unit are the basic terms used in error and data analysis, then accuracy, precision, then types of errors, and how to eliminate, detect as well as eliminate these errors. And now we are going to see in today's class, we are going to see curve fitting, methods of least square, significant figures, and computational rules. So I'll start with curve fitting. So what do I mean by curve fitting? Curve fitting is nothing but it's a graphical method to represent the experimental data. So curve fitting is nothing but it's a graphical method. நம்ம graph போட்டு நம்ம கிடைச்சிருக்க reading வந்து கரெக்டாக தப்பான்னு வந்து we can predict. Is it okay? So for this purpose, what you have to do is, if you have a set of data, you consider it as two variables x and y and plot a graph between x and y. You get a straight line and all the points will not fall on this straight line. Some will deviate and some will fall on the line, and if the deviation from the line is said to be minimum, then we call the line as best straight line to fit the data. So if most of the points are falling in the line, the data what we have obtained is said to be correct. So this method we call it as curve fitting. Is it clear? I'll repeat the point once again. So what I mean by curve fitting is nothing but it's a graphical method of representing the experimental data. So you consider your data into two variables x and y. You draw a plot between x and y. As you draw a plot, what will be getting there is you get a straight line and all the points won't fall on that line. If the points are not falling in the line, we call by the word deviation. We have studied deviation. Okay, and if the deviation is found to be minimum, then we call the line as straight line to fit the data. It's clear? And this is a graph. I'll show you the graph how it will come normally is it will be like this. Is it okay? So input you can take it as the x-axis and output we can give it as the y-axis. So these are the two different things we are plotting, and we draw a straight line which proves whether the data for us is said to be correct or wrong. And if most of the points are falling in this line, we call the curve as best straight line to fit the data. This is one method. Okay. Next method is method of least squares. Method of least squares. So what do you mean by this method of least square is previous method I have said it is a graphical method. Okay, and this is a statistical method. What do you mean by statistical method? It is nothing but by using formulas or mathematical derivations you are able to prove whether the data is found to be correct or wrong. Okay, so what you have to do here is you bear in mind the best line fit. Okay, bear in mind, and after that what you have to do there is you collect the deviated points from that. The sum of the squares of the deviation of the points from the line is, if it is found to be minimum, then we call this is said to be the correct data. And how to do the thing is, it is done by two steps. I'll say later. So I'll repeat the same point once again. So what do you mean by method of least square is nothing but it's a statistical method to represent your data. Okay, and if the deviation is found to be minimum, what you do there is use the formula d1 square plus d2 square plus d3 square to the least value you have to calculate. Then you have to follow two steps. The first step is the variables, as I said previously, it has to be taken into two variables x and y, and you have a straight line equation. We all of us know the equation. Y is equal to, we have studied as y is equal to mx plus c, and it is given here as y is equal to ax plus b, where a is the slope and b is the intercept. You can see the diagram, you can understand this. You get a straight line and the point between this x and y is said to be your intercept, and on the line, you get a thing called this intercept. And we can use the formula finding the slope and intercept. We have two different formulas. I'll say you later. So this is the first step in this method of least square. What you have to do there is you arrange the variables as x and y. Then what you have to do is you draw a straight line with the equation y is equal to ax plus b. And the second step what you are going to do is you have to calculate the slope and the intercept. And the value for slope is nothing but a is equal to n into sum of xy minus sum of x sum of y divided by n sum of x square minus sum of x the whole square. Is it okay? So this is the formula for slope, and the formula for intercept is sum of y divided by n minus a into sum of x by n. This is the formula for slope. Is it clear for you? So first thing we have seen is nothing but slope, and second one what you have seen is it to be the intercept. So these are the two formulas to be used. So I'll give an example for that. A thing is being asked. Fit a straight line using the method of least square of the following data. Two variables are given, x and y. So what you have to do here is you form a table like this, and we know the equation. It is nothing but y is equal to ax plus b, where a is the slope and b is the intercept. A is the slope and b is the intercept. And what are the terminologies we are in need of? We are in need of x, y, x square and xy. So using these terms you can find the value of slope. Also you can find the value of intercept. And if you have to arrange the values, x is nothing but 0, 1, 2, 3, 4. And y is nothing but 1, 1.8, 3.3, 4.5 and 6.3. And if you square the values, you get the value as 0, 1, 4, 9 and 10. And multiply x and y, you get 0, 1.8, 6.6, 13.5 and 25.2. We are in need of summation of all these things. You add up all the things individually. Okay. After adding, you substitute in the formula. And what you get here is n is number of pairs of x and y is nothing but 5. So you substitute in the value of a, also you substitute in the value of b, and a value is found to be 1.33, which is nothing but the slope, and b value we are getting is nothing but 0.72. So what you have to do here is we have the formula y is equal to ax plus b. You substitute there, y is equal to 1.33x plus 0.72. So this will give you how the your data fits the straight line. If there is much deviation, you can conclude to the point the data are not correct. Is it okay? So next point what you are going to see for today's class is significant figures. What do you mean by significant figures? So what I mean by significant figures is it's nothing but is defined as all digits that are certain plus one doubtful digit with some uncertainty. புரியுதா? So நமக்கு கொடுத்துருக்க எல்லா டிஜிட்டும் சர்டனாக இருக்கும், ப்ளஸ் ஒரு எக்ஸ்ட்ரா டவுட்ஃபுல்லான டிஜிட் வந்து இருக்கும். ஸோ திஸ் வி கால் இட் இஸ் சிக்னிஃபிகண்ட் ஃபிகர்ஸ். ஆல் டிஜிட்ஸ் தட் ஆர் certain plus one doubtful digit with some uncertainty is called as significant figures. If I am saying this example, you can clearly understand. So what's the example given here is you consider a burette which is graduated as 0.1 ml interval. We have such burette in our lab, okay, 0.1 ml interval. So now the volume to be measured is accurately up to the first decimal. Is it okay? And our example is we have to measure a volume of 5.2. So we can read this 5.2 value very accurately with certainty. If the volume is measured as 5.23 ml. So what happens here? The second decimal is doubtful and it is said to be uncertainty. Thus, reading of 5.23 contains three significant figures. Among the three, two are said to be certain and one is said to be uncertain, and this is said to be significant figures. Is it clear? I'll repeat the point once again. So whatever thing the bureau or something, whatever graduation we are doing, up to that point we can measure. Beyond the thing it is said to be doubtful, and this we call it as significant figures. Okay. If you to correctly say about significant figures, we have 4 rules. Based on those 4 rules, we can say whether the given number or the given value is found to be significant or it is said to be insignificant. It's clear. I'll repeat the point once again. So, for assigning the significant figures, simply we can't say this value is found to be significant and this value is found to be not significant. We can't say. So 4 different rules we have. Based on that rules alone, we can say whether the given value or the given answer is found to be significant or not. I'll say that one by one. So recognition of significant figures. What is the first rule here? All non-zero digits are said to be significant. All non-zero digits are said to be significant. So உனக்கு ஒரு வேல்யூ கொடுத்துருக்காங்க 786 centimeter. So இதில் பார்த்தீங்கன்னா if you take the 3, all the 3 are said to be significant. Why we say it is significant? எதுவுமே அதில் என்ன இல்லை, 0 இல்லை. So all non-zero digits are said to be significant. So it can be written as 7.8, 78.6, or you can write 0.786. whatever way நம்ம எப்படி பார்த்தாலுமே இதில் எவ்வளவு significant figures இருக்குன்னு பார்த்தீங்கன்னா 3 significant figure இருக்குது. இட்ஸ் clear for you. The last digit we are writing 0.786. அதில் நம்ம 4 significant figure சொல்ல மாட்டோம். ஏன் சொல்ல மாட்டோம்னா 0 is said to be insignificant figure. 0 எப்போ significant எடுக்கணும்னு I'll say you later. First point clear ஆயிடுச்சா? So all non-zero digits are said to be significant. I have given you example. And the second point is 0 before and after the decimal point are not significant. So this is a second rule. How to consider the second rule? Second rule says that 0 before and after the decimal point are not significant. 0 before and after the decimal point are not significant. So 0 வந்து பாயிண்ட்டுக்கு முன்னாடியோ பின்னாடியோ சும்மா இருந்துச்சுன்னா it is not significant. And 2 examples are given here. The first one is 0.02. இதில் எவ்வளவு significant figures பார்த்தீங்கன்னா ஒரே ஒரு significant figure தான் இருக்குது. ஏன்? It is 0.02. 0 is not taken into consideration. Another example is 0.022. Here we have 2 significant figures. Here also we don't consider this 0.0. Is it okay? So next rule is terminal zeros are significant. எந்த zero significant? Terminal zero. Terminalனா லாஸ்ட்டில் வர ஜீரோ வந்து சிக்னிஃபிகண்ட். அதுவும் நம்ம எப்படி தான் கன்சிடர் பண்ணோம்னா அதுக்கு முந்தினது எதுவாக இருக்கணும்னா இட் ஷுட் பி எ நான் ஜீரோ digit. It should be a non-zero digit. That is 0 right of last non-zero digit is said to be significant. அதான் terminal zero. டெர்மினல் ஜீரோனா என்னென்னா அதுக்கு முந்தின நம்பர் எதுவாக இருக்கணும்னா ஒரு நான் டிஜிட் ஜீரோவாக இருந்துச்சுன்னா அதை நம்ம என்ன பண்ணோம்னா we take into consideration and it's said to be a significant one. So if you take the first one, the first example is 3.05. இங்கே பாயிண்ட்டுக்கு அப்புறம் தான் ஜீரோ இருக்குது. பட் என்ன டிஃப்ரென்ஸ்னால் முந்தின இதுக்கும் என்ன டிஃப்ரென்ஸ்னால் 0.0க்கு முன்னாடி ஒரு 3 இருக்குது. ஸோ திஸ் we call it as terminal zero. This we call it as terminal zero. அதுக்கு முந்தினது ஒரு நம்பர் இருந்துச்சுன்னா நம்ம என்ன பண்ணோம்னா we take that particular thing as at terminal zero and that zero is said to be significant. So if you take this 0, 3.05, if you take the figure here, 3 is a figure, 0 is a figure, again 5 is a figure. So we have 3 significant figures. And next example is 10.2050. இங்கே பார்த்தீங்கன்னா லாஸ்ட்டில் தான் ஜீரோ வருது. பட் அந்த லாஸ்ட் டெர்மினல் ஜீரோக்கு முந்தின நம்பர் இஸ் செட் டு பி அ நான் ஜீரோ டிஜிட். அதனால இந்த ஜீரோ என்ன எப்படி எடுத்துப்போம்? இட் இஸ் ஆல்சோ செட் டு பி சிக்னிஃபிகண்ட். ஸோ வி கால் திஸ் ஆல்சோ a significant figure. So if you take this one, there are 6 significant figures. I'll repeat the 3 once again, then I'll go with the 4th point. Okay, Amma? So I'll repeat. So rules for significant figures. So what are the rules you have to follow? First one is all non-zero digits are significant. So 0 தவிர்த்து வர என்ன நம்பர் இருந்தாலும் நம்ம என்ன பண்ணிடுவோம் அதை significant figure எடுத்துப்போம். அதான் ஃபர்ஸ்ட் பாயிண்ட். செகண்ட் பாயிண்ட் என்ன சொல்கிறோம்? பாயிண்ட்டுக்கு முன்னாடியோ பாயிண்ட்டுக்கு அப்புறமாவோ 0 வந்துச்சுன்னா it is said to be non significant. It is not significant. Third one what you are saying is terminal zeros are significant. என்ன zero significant? பாயிண்ட்டுக்கு முன்னாடியோ பின்னாடியோ 0 வந்துச்சுன்னா நார்மலாக அது என்ன இல்லை, சிக்னிஃபிகண்ட் இல்லை. பட் டெர்மினல் ஜீரோஸ் ஆர் சிக்னிஃபிகண்ட். டெர்மினல் ஜீரோ எப்படி ஞாபகத்தில் வச்சுக்கோங்கன்னா, அந்த ஜீரோக்கு முந்தின டிஜிட் வந்து ஒரு நம்பராக இருந்துச்சுன்னா அது என்னது, இட் இஸ் செட் டு பி டெர்மினல் ஜீரோ அண்ட் தட் ஜீரோ வில் பி டேக்கன் அஸ் அ சிக்னிஃபிகண்ட் ஃபிகர். இட்ஸ் கிளியர் now? Shall I go with the fourth point? I think you're able to follow the thing. Yes, I'll go with the fourth rule. So coming to the fourth rule, very small and very large number are written in standard exponential form and are significant and are recognized. Very small as well as very large numbers are என்ன படிப்போம், is right in the form of exponential form and they are said to be significant figures. They are said to be significant. இப்போ ஒரு weight கொடுத்துருக்காங்க என்ன, if a weight of 24.0 gram is expressed in milligrams, it should not be written as 24,000 milligram. நம்ம எழுத மாட்டோம். How we write normally? 24.0 into 10 to the power of 3. Or we write 24.0 gram. Simply we can write 24.0 into 10 to the power of 3 milligram. Again we can write 2.40 into 10 to the power of 4. So இதில் எல்லாத்துலேயுமே பார்த்தீங்கன்னா, if you see these example, what you can understand here is the number which is before 0 is said to be a number. Here also a point decimal is there, but it is said to be terminal 0. Then a 0, terminal 0. Also we can take into consideration it is an exponential formula எழுதும்போது நம்ம என்ன பண்ணுவோம், அதை வந்து significant figure நம்ம எடுத்துப்போம். Very small or large number is written as a exponential form and those figures are said to be significant figures and they are said to be recognized. அதை நம்ம என்ன பண்ணுவோம், கன்சிடர் பண்ணுவோம். எக்ஸ்பெனன்ஷியல் எழுதும்போது அதை நம்ம கன்சிடர் பண்ணுவோம். ஸோ அதனால் இஃப் யூ டேக் 24.0 பாயிண்ட்டுக்கு அப்புறம் இந்த 0 வந்தாலும் இது நம்ம என்ன பண்ணுவோம், இது 10 to the power of 3 இருக்கிறதுனால we say there are 3 significant figures. Is it clear? Next one, it is 2.40 into 10 to the power of 4. Here also we have 3 significant figures. இதெல்லாம் 2, 4, 0. Is it clear? So these are the 4 different rules for recognizing significant figures. It is clear for you? So I think you are clear with significant figures. Next we can see computational rules. What we are going to see? Computational rules. So what I mean by computational rule is, in order to count the significance in a numerical value of an experimental data, the following rules are followed and these rules we call it as computational rules. ஸோ நம்ம எக்ஸ்பெரிமெண்ட்லாம் செய்து முடிச்சிருவோம், கரெக்டாக தப்பானலாம் பார்த்து முடிச்சிருவோம். இப்போ ஃபைனலாக நம்ம என்ன பண்ண போகிறோம், அந்த டேட்டாவை we are going to type in a system and we are going to present. நம்ம ஒரு ரெக்கார்டு அதை வந்து வைக்க போகிறோம். ஸோ அதை ஃபைனலாக அதுக்கு கொஞ்சம் ரூல்ஸ் வந்து ஃபாலோ பண்ணணும். அது அடிஷனாக இருந்தால் என்ன பண்ணணும், சப்ராக்ஷனாக இருந்தால் என்ன பண்ணணும், ஒரு டெசிமலாக இருந்தால் என்ன பண்ணணும், லாக் எடுத்தால் என்ன பண்ணணும், then anti-log எடுத்தால் என்ன பண்ணணும், then if it is said to be multiplication, what you have to do. So there are certain rules for this and these rules we call it as computational rules. Computational rules. So I'll repeat the purpose of computational rule is nothing but in order to count the significance in a numerical value of a experimental data, we follow certain rules. Mainly we have 3 rules: rounding up of numbers, then addition or subtraction, multiplication or division. So these are the main things followed. In addition to this multiplication or division, we have logarithm or anti-logarithms. I'll say one by one. Okay ma? First we can say what is said to be rounding of numbers. நம்ம நீங்கள் நார்மலாக நம்பர் எழுதும்போது உங்களுக்கு ஞாபகம் இருக்கும். You remember, if after the decimal, if it is found to be less than 5, அல்ல சும்மா நம்பராக இருக்கும்போதே if it is found, நம்ம என்ன பண்ணுவோம், if it is found to be less than 5, we take into consideration. We don't take into consideration. If it is found to be less than 5, we don't take into consideration. If it is found to be above 5, we take into consideration. That's the first rule. So rounding of numbers, I'll say. So what I mean by rounding of numbers is, in order to get the significant figure of the experimental data, if last digit is less than 5, it is rejected. I'll repeat. If the last digit is less than 5, it is rejected. If it is 5 or above 5, the last but one digit is increased by 1 to round off the experimental result. It's clear for you? I'll repeat the point once again. First rule is nothing but rounding of numbers. Rounding of numbers. Rounding of numbers, what you are going to do? In order to get the significant for the experimental data, what you have to do there is, you have to see the value. Okay. While seeing the value, you see the last digit. If the last digit is found to be less than 5, we have to reject that digit. Okay. If it is found to be above 5 or it is 5, we have to add, you have to increase by 1 the round off value to get the result. Is it okay? So that is given by an example here. It's nothing but 6.64 has to be rounded as 6.6 because 4 is last digit, 4 is found to be less than 5. And second example is nothing but 7.866 because it is found to be greater than 5, the last digit, we have to take it as 7.87. It's clear? So this is something about rounding of numbers. Rounding of numbers. Okay. So next thing what you are going to see is addition or subtraction. Addition or subtraction. So for addition or subtraction, what is the rule here is, in addition or subtraction, the result is reported the same number of decimal places as that of the number with the least number of decimals. நமக்கு ஆட் பண்ணும்போதோ சப்ராக்ட் பண்ணும்போதோ எதுக்கு லீஸ்ட் நம்பர் ஆஃப் டெசிமல் நமக்குள்ள ஒரிஜினல் நம்பரில் இருக்குதோ ஆன்சர்லேயும் அந்த லீஸ்ட் நம்பரில் டெசிமல் நம்பர் தான் நம்ம எழுதணும். அதோட கூடுதலாவோ குறைவாவோ உள்ள டெசிமல்ஸ்க்கு நம்ம என்ன பண்ணக்கூடாது, addition or subtraction answer வந்து எழுதக்கூடாது. So I'll give an example for you. The first number is 5.63 plus 3.985 plus 25.1 will give you 34.715. இதை எப்படி நம்ம ரவுண்ட் அப் பண்ணணும்னா, we have to round it up to 34.7. ஏன்? Why we are rounding up to 34.7? இதில் ஒரு third digit பார்த்தீங்கன்னா, third value பார்த்தீங்கன்னா, it is 25.1. ஸோ ஃபர்ஸ்ட் ரெண்டு நம்ம என்ன பண்ண மாட்டோம், கன்சிடர் பண்ண மாட்டோம். யாருக்கு மினிமம் டெசிமல் இருக்கோ அந்த நம்பர், நம்ம ஒரிஜினல் நம்பரில் அந்த நம்பரை பார்த்துட்டு தான் நம்ம ஆன்சரை வந்து கரெக்ட் பண்ணி செக் பண்ணி ரவுண்ட் அப் பண்ணி வைப்போம். Is it okay? So I'll repeat the example once again. So 5.63 இருக்குது plus 3.985 plus 25.1. Your answer is 34.715. So what you have to do here is, you round up the value to 34.7. Okay. The reason it's given there, 25.1 is the least number of decimal place. Similarly, another example, 14.23 plus 8.145 minus 3.7645. The answer is 18.6205. And we are rounding the answer as 18.62 because the first value is 14.23. Is it clear? So this is in the case of addition or subtraction. Okay, now we are going to see if it is multiplication or division, what you have to do. If it is said to be multiplication or division, the result must be reported with the same number of significant figure as that of the number of the least number of significant figure. நம்ம ப்ரீவியஸில் என்ன பார்த்தோம், கொடுத்துருக்க ஒரிஜினல் வேல்யூவில் மினிமம் டெசிமல் யார் இருக்கோ அந்த டெசிமலுக்கு நம்ம ரவுண்ட் ஆஃப் பண்ணி வைக்கணும். மல்டிப்ளிகேஷனில் என்ன பார்க்கணுன்னா, யாருக்கு லீஸ்ட் நம்பர் ஆஃப் சிக்னிஃபிகண்ட் ஃபிகர்ஸ் இருக்கோ அதுக்கு நம்ம ரவுண்ட் ஆஃப் பண்ணணும். Okay, so if you take the example here, it is 2.583 into 3.4 is equal to 8.7822. It is rounded to 8.8. ஏன் 8.8 நம்ம round பண்ணுறோன்னா, second value it has only two significant figures. So your answer is also said to have two significant figures because 3.4 has two significant figures. Similarly, 69.73 divided by 80.5. Your answer is 0.8662. The value has to be rounded to 0.866. The reason is, if you see the second value 80.5, we have only three significant figures. So your answer should be rounded to three significant figures. Okay. And next, it's clear. So now we have seen, what are things we have seen now? rounding of numbers, then we have seen addition or subtraction, and third one multiplication or division, and last one we can see how to go with logarithm and anti-logarithm. And if it is logarithm and anti-logarithm, what you have to do here is, if you are going to take a log normally has two parts. One is said to be a whole number plus a fraction, and fraction is called as Montesa. Fraction is called as Montesa. What you have to do here is, for logarithm and anti-logarithm, keep as many digits as in the Montesa as the original number. ஸோ உனக்கு டெசிமல் பாயிண்ட்டுக்கு அப்புறம் எவ்வளோ நம்பர்ஸ் இருக்கோ அவ்வளோ நம்பர் நம்ம என்ன பண்ணிக்கலாம், லாகுக்கோ ஆன்டி லாகுக்கோ நம்ம வச்சுக்கலாம். இஸ் இட் கிளியர் ஃபார் யூ? ஸோ திஸ் இஸ் சம்திங் அபவுட் லாகிரிதம் அண்ட் ஆன்டி logarithm. So the log of 2.4 into 10 to the power of 5 is 5.3802. It's rounded up to 5.38 since the original number has only two numbers. The original number has only two numbers. The anti-logarithm of 1.98 is 0.9550. It is rounded to 0.96. So decimal க்கு அப்புறம் எத்தனை digits இருக்கோ நம்ம என்ன பண்ணிக்கலாம், that thing we have to take into account. Is it okay? It's clear now? Yes? Okay. So we can have a short recap of the thing what you have seen today. So the last topic of this unit is nothing but curve. First one we have seen for today's class is curve fitting. Then we have seen methods of least square. Then I have explained you what is significant figures and what are the rules has to be followed to say it is said to be a significant figure. And finally we have seen computational rules. And in computational rules, four different things we have seen. One is rounding of numbers, then addition or subtraction, then multiplication or division, and final one is logarithm or anti-logarithm. So I think you are clear with the topic. So with this, the second unit is over. Thank you. Thank you for listening. Keep on studying, ma. Thank you.